Hey everyone, and welcome. Today, we're going to crack open a really cool mathematical secret: how to count all of your possible choices without actually having to count them one by one. Seriously. This is the key to understanding everything from picking out an outfit to figuring out the odds of hitting the lottery. So, let's get right into it.
All right, let's start with a really simple question. Just look at what you're wearing, or maybe what's in your closet. Let's say you've got 5 different shirts and 3 pairs of pants. How many different outfits can you actually put together? Go ahead, take a guess. The answer, well, it's going to reveal the core idea we're exploring today.
Yeah, the answer is almost always way more than you'd guess at first. And that's because there's a really simple mathematical principle working behind the scenes, one that opens up this hidden world of possibilities all around us.
So, how do we actually figure this stuff out? Well, it all starts with one single foundational rule. Think of it as the engine that's going to drive everything else we talk about. It's called the fundamental counting principle. And honestly, it's as simple as it sounds. You just multiply your choices together. Imagine you're at a restaurant, right? The menu has 3 appetizers, 5 main courses, and 2 desserts. Now, to find out how many different 3-course meals you could order, you don't have to list them all out. You just multiply. 3 times 5 times 2. Boom, that's 30 possible meals. It's simple, it's powerful, and best of all, no counting required. Okay, but what happens when the order of your choices suddenly becomes super important? This is where things get interesting and where we meet our first major concept: permutations.
So a permutation is just a selection where the order is absolutely vital. Think about a race with 3 runners. Let's call them Alice, Bob, and Carol. An outcome where it's Alice first, Bob second, Carol third is a completely different reality from Bob first, Alice second, Carol third. See? The runners are the same, but the order changes everything. That, right there, is the heart of a permutation.
Now, to calculate all those different permutations quickly, mathematicians have this really handy tool called a factorial. It's just that little exclamation mark you see. So for our 3 runners, we'd calculate 3 factorial, which just means 3 times 2 times 1. And that gives us 6 possible ways they could finish the race. It's a fantastic little shortcut for a really powerful calculation. But what if the order is totally irrelevant? What if all that matters is who you pick, not the sequence you pick them in? Well, this simple shift changes the entire game, and it brings us to our next key concept. And this is a combination, a grouping where order is completely meaningless. So let's go back to Alice, Bob, and Carol. But instead of a race, we're just picking them to be on a project team. So is the team of Alice, Bob, and Carol any different from the team of Carol, Bob, and Alice? No way. It's the exact same group of people. In this case, the order you pick them in has 0 importance. And the implication of this is huge. By saying order doesn't matter, we get to eliminate a ton of outcomes that we were counting separately before. All the different arrangements of Alice, Bob, and Carol now just count as one single combination. This is the fundamental reason why you'll always have fewer combinations than permutations when you're working with the same group of items. So, now we've got these 2 powerful ideas: permutations and combinations. But how in the world do you know which one to use? Well, it turns out it all boils down to asking yourself one single, simple question. This slide really lays it all out, side by side. For permutations, order is king. Think about arranging books on a shelf, those race results, or even a password. PASS is obviously very different from SSAP. But for combinations, order is totally irrelevant. You're just grouping things, like picking a project team or choosing your lottery numbers. The real key here is that distinction between arranging and grouping. And this brings us to the golden rule. This is the one thing you have to remember. The first question you always ask yourself is this: is the order of the items important to the final outcome? Your answer to that one question immediately tells you which path to take. So let's put this all together into a super simple checklist. Step 1, look at the problem. Step 2, ask that golden question: does the order matter? If your answer is yes, you're dealing with a permutation. If your answer is no, it's a combination. That's it. That's the core logic you need to solve any of these kinds of problems. So to leave you with one final thought, think about the lottery. When you pick your numbers, does the order they're drawn in matter? Or does it only matter which numbers get drawn? Using what you've just learned, you can now understand exactly why the odds of winning are so astronomically long. It's all just a matter of counting without counting.